Hey guys, just going to start doing some revision on graphs. We'll start off with a linear equation. This one's x minus 2y is equal to 5. The first thing that you should remember about linear equations is there's two ways of writing them. One is in the general form, the other way is in the form y is equal to mx plus b, the gradient intercept formula, and that's the formula that I like. So I'm going to rearrange this, so I'm going to write it minus 2y equals, and it's going to be 5 minus x. I'm going to divide top and bottom by minus 2, so I'm going to have y, I'm going to divide it by negative 2. So this becomes minus 2.5, and this becomes x over 2. If I rewrite it, it is a half x minus 2.5. Alright, so we have our equation in the general form, and we have a y-intercept of minus 2.5. Our x-intercept can be found by making y equal to 0, and in this case what I might do is I might grab the original equation, x minus 2y equals 5, and substitute from there. So 2 times 0 is 0, so you just have x is equal to 5. So given that we have the y-intercepts, the y-intercept and the x-intercept, remember that we actually get two points. So the y-intercept, x is 0, so we have 0 minus 2.5. The x-intercept, which is on the x-axis, we have y is equal to 0, so we have 5, 0. This is enough to plot 2 points, which will give us a linear equation. Okay, so I just need a bit of space. I'll move it over here and I'll start plotting. Now this is only a rough sketch. Technically it's not graphing because I'm not using a ruler. I plot my points, so the point 0 is there on the x-axis, down 2.5, so it's going to be somewhere about here, and I write minus 2.5 there. The point 50 starting at the origin, across 5, and I don't go up or down because it's 0. So I'll plot the point there, and I'll just mark the x value. I have 2 points. I know it's not perfect, but that's the line crossing through these 2 points, so I might just fudge it a bit. As usual, guys, basically that's it. There you go. While I'm at it, guys, I'll graph this quadratic equation. So it's y is equal to x to the power of 2 minus 4. For this equation, guys, we can do it a couple ways. We can just think about it as typical concave up parabola, except it's minus 4, so it's actually going to cross over at minus 4, and that's pretty much it. The x-axis will be up there. I'm not going to do it that way, actually, because I don't think it's smart enough. We're better than that. Instead, what I'm going to do is I'm going to rewrite the equation using factorization. You can see there that y is equal to x squared minus 4 is actually the same as y is equal to x squared minus 2 squared. Now this is what we call the difference of two squares, and if you remember from your factorization, this factorizes into x plus 2 and x minus 2. And if you don't believe me, you can expand it out and see if it works. It will. So if we let y equals 0, we'd be finding the x-intercepts. So 0 equals x plus 2, bracket, x minus 2. So, if we make this part 0, this part is 0, which makes the equation true. So I'm going to write 0 equals x minus 2. In that case, it's pretty easy to get, x is 2. Once again, if this part is equal to 0, that means this whole thing is equal to 0, which makes the whole equation true. So I'm going to write x plus 2 equals 0, and that's pretty easy to see. It makes x is equal to minus 2. I'll gather from these two bits that we have the points 2, 0, and minus 2, 0. These are sometimes called the roots of the equation. Now, just to make sure we cover all the bases, I also need to do the y-intercept. Remember that the y-intercept occurs when x is equal to 0. And this is pretty easy to do. I get my first equation, because it's easier to do for the first equation. Y is equal to x squared minus 4. If I substitute in x is 0, I get y is equal to just minus 4. So I have my second point, 0 minus 4. Now I'm going to plot our 1, 2, 3 points into the equation, onto the plane, and make sure it looks right. So just give myself some space over here and begin to plot. We have a y-axis, we have an x-axis. First point, 2, 0, so once again we start at the origin, across 2, up and down, nothing. So there, I'll mark that there as 2. Same point, minus 2, 0, goes across here, so minus 2 there. The next point, 0, minus 4. So we go down the y-axis to minus 4. Now of course guys, I am not using a ruler because this is just a sketch. It's not technically graphing. Okay guys, so this is a concave up equation. Going through these 3 points, and we'll go somewhere like that. And there you have it. It wasn't too much working out. Be able to, but here we go. Y is equal to, and I want to change all of these to positives. Positive 2x. Well, actually, I'm not changing them to positives, I'm changing the sign of each. Plus 2. Now, the way that I solve an equation like this, and I'm just going to jump straight into solving it. Now I've said y is equal to 0, which means that I'm finding the x-axis, the x-intercept. I'm going to go 2 times 2, and that gives me 4. What I'm really looking for is a number that will multiply to 4. And you see there, the sign here, well actually no, sorry, the sign there, it's positive. So a number that multiplies to 4 that has a sum of 5. Now that number will be 4 and 1. The way that I continue to do this, 0 equals 2x squared, and I'm going to separate the minus 5 into minus 1x and minus 4x plus 2. Factorise it, factorise it separately. X outside of 2x minus 1, and I'm going to put that outside of minus 2, 2x minus 1. Okay, so you're wondering what's the point? It's good to notice, guys, that this is the same as that. So, rewriting it over here. Actually, I want to rewrite it up over here. 0 equals. Let me just move this across slightly. X minus 2. Now, I've written out the factor in front of those two brackets. Bracket 2x minus 1. So, we have now it fully factorised. What we need to work out is, given that y is equal to 0, which will find us the points on which this curve hits the x-axis, or the x-intercepts, what is x equal to? So remember, if this is equal to 0, the whole thing's equal to 0, which means this is true. So I'm going to write x minus 2 equals 0, add 2 to both sides, x is equal to 2, so I have the point 2, 0. Once again, if this is equal to 0, the whole thing's equal to 0, which means the whole thing's true. So I'm going to write 2x minus 1 equals 0, so 2x is equal to 1, x is equal to a half. So I have the point 1 over 2, 0. I have my 2 points. I am not going to find the y-intercept now. Or will I? Well, you know what, it's not actually that hard to find, so I will. Going back to the equation, if I just want to find the y-intercept, it's pretty easy. Y is equal to minus 2x plus 5x minus 2. Now, if x is 0 here and there, the whole thing there is 0, so y is just equal to minus 2, so I have the point 0 minus 2. And that's pretty easy to follow, I think. Let's graph it. The points that I need to find, I didn't know I could do that. The points that I need to find or use are 2, 0, so I'm going to draw the point. I'm going to move this first before I cause any damage. 2, 0, so across 2, 0. Half 0, across a half, 0. Right a half there, right 2 there. The point at which it hits the y-axis. Now this should make sense. 0 minus 2. So 0 minus 2, 0 down 2. That doesn't make sense, does it? Actually, let's just go back over here. Now the equation, the original equation, has a coefficient of minus 2. The x squared has a coefficient of minus 2, which means that the equation is concave down. So if I move this stuff over there again, if it's concave down, this is what it looks like.